So the properties, in summary, properties of X-rays. So we were able to state 8 of them. So we said one of the properties of X-rays is that they are not deflected by magnetic and the magnetic fields and the electric fields, and therefore we say that they are not charged. Number 2, we say that X-rays will undergo diffraction and they are plane polarized, so they are waves. They are waves in nature. Then we also said as part of the electromagnetic spectrum, travel at the speed of light, which is 3 × 10⁸ meters per second. Again, with the X-rays, we say that they cause fluorescence in certain substances. Like the zinc sulfide, they cause fluorescence. They will cause fluorescence in certain substances. That is another property of the X-rays. Then we also say that X-rays affect photographic emulsions. Affect photographic emulsions. That is another property of the X-rays. We also say that they ionize. You can use Z or S. They ionize gases, making them conductors. That's another property of the X-rays. We also say that they cause photoelectric emission, a topic discussed later. They cause photoelectric emission. Then we can also say that they penetrate matter. They penetrate matter, and we say that with least penetration occurring in metals of high density. So those are 1, 2, 3, 4, 5, 6, 7, 8. So these are the properties of X-rays in summary. Then again, we went ahead and looked at energy of X-rays. Energy of the X-rays. Having said that X-rays are waves in nature, we can start with the first formula, which is the wave equation. C is equal to wavelength multiplied by the frequency. Then we say that energy is directly proportional to frequency, so it is equal to hf, where h is the Planck's constant. And again, we say that energy is the same, is given by electron charge multiplied by the accelerating potential difference. And therefore, from this we can say that energy EV is equal to the Planck's constant multiplied by frequency. And from this we can see that frequency is the speed of light all over the wavelength. So it will be Planck's constant all over the wavelength. So those are the formulas that you need to make note of, very important, and they'll help you in calculation of other questions. So you can see we have electron charge multiplied by the accelerating potential difference. Then we have the Planck's constant, we have the speed of light, which is now the speed of the X-rays all over the wavelength of the X-rays. So that is on energy of X-rays, so you should be able to use those formulas. You should be able to explain what each stands for and the SI unit.